Hello and welcome to day 14 of our Cloud Run series. So today we are going to do a bit of a deep dive into event-driven architectures in Cloud Run. This is a bit related to what we did yesterday on Cloud Run jobs. So what we are going to look at is how we can run our Cloud Run services based on events. So these events can be from Cloud Scheduler, these events can be from PubSub, and also Eventarc. Now, the core concept behind this is we are trying to move away from synchronous communications into asynchronous communication, right? You can ignore the spelling mistake. It was an image generated by Gemini. So when we look at asynchronous communication, as you can see on the right, you have, let's just say, for example, you are calling someone, right? Now, you need to maintain that communication if you need to get your message across, right? The person cannot along the way stop or cancel the call and then still be able to receive whatever message you wanted to give them. So if you want to pass on to the receiver or the person some kind of a message, they need to wait till you have completely passed on the message before they can move on, right? Else they might not receive the message at all, or they might get just a portion of the message. Now, on the other hand, if you look at asynchronous communication, which is shown on the left, you can have a situation where the mails or the messages come in, you put them into a queue or you put them into some sort of an inbox, and the client could answer them, you know, once they wake up, the client could take them and read them one after the other, right? And this is not actually, what we are looking at in the sense of what we are looking at, because our services are always going to be working. They are not like, a human being that is probably going to sleep for a while before they answer your mail. But the idea is the same. You do not need the service does not need to wait for you whilst you are processing that message, but you can keep that message into some sort of a queue, and then the service can answer it as and when it becomes free. So the service can take the first one or the first message in the queue, answer it, and then once it is free, it looks at the queue for, okay, is there any other message? And then it answers it. So the service is able to kind of process messages in that manner without having to wait till you complete before it handles that message. From I think day 1 to day 12, we've mostly been doing synchronous programming, right? So we have some kind of an event, like we visit some website that we've created, and then we perform some action. So we've mostly handled synchronous communication, right? Now, with asynchronous, we are decoupling that communication. So even if the sender drops off, the receiver can still process that message later on, because there is a queue for that receiver to pick the messages from, right? And this gives us some level of resilience that we might not have with asynchronous communication. So synchronous communication, both the receiver and then the sender need to stay on in order for that communication to be successful, right? And if you are having, let's just say, a checkout service, and for some reason your invoicing fails, you do not want to fail the whole checkout process, because it might be just a problem with the invoice. So you probably want to implement some form of retries just for the invoice, but you also don't want the user to be waiting for that retry to complete. So you will still continue with your checkout process, and then you might, let's say, kick off some other processes to retry or to make sure that your invoice gets back up. Now, we are going to look at the three triggers. So one of them, or the first one that we are going to take a look at, is Cloud Scheduler. The role of Cloud Scheduler is maybe similar to what your alarm clock can do. And what it allows you to do is it allows you to schedule events and then perform certain actions. What Cloud Scheduler will do is it would allow you to create an event that should happen at a particular point in time. So if you want your reports to be generated at 8 a.m. every day, if you want some action to happen at a particular point in time, you can then use Cloud Scheduler for that use case. So you can connect Cloud Scheduler to your Cloud Run service to make sure that those reports are generated on time without the user having to go to the dashboard and click on a button at maybe 8 a.m. or 10 p.m. for some particular action to happen. So this has its use cases. So if you want to send maybe daily reports, daily emails, you want to do daily database cleanups, right? So those are use cases where you might want to use the Cloud Scheduler trigger. Now we look at PubSub, right? PubSub is a different topic altogether. It's a topic that we probably have to find some other time to discuss a bit more. But to simplify the whole PubSub process, if you've ever worked with any system that kind of handles communication through messages. That is what PubSub basically does. And so it allows you to be able to create a topic which you can have subscribers to, and those subscribers can then receive messages from that topic. And this allows you to decouple your services. So it is a very good architecture when it comes to microservices. Um, you can also find this type of architecture in even, let's just say, any kind of event processing service that you have. You can also find this architecture. You can imagine a situation where you are processing an order. So if an order comes in, you want to perform multiple processes. Now, if these processes, even if they are dependent upon each other in some way, you can architect it in PubSub. So what you can have is, let's just say when the checkout event happens, you publish a message. So that message can contain information about that checkout event. You can publish it to a topic, and then you can have multiple services that subscribe to that message. So you can have one service that basically handles sending of text messages about that order, another service that handles sending of emails to the client, another service that handles updating the database of the warehouse. So you can have multiple services that perform different actions when you get a message. So in this example, for instance, we have one service that is handling emails, one service that is handling analytics, one service that is handling sending some welcome gift. And these services can also further publish messages. So in the end, you end up with an architecture where the services don't need to know about each other. They just communicate through messages. So if I am the mail service and after I am done sending the mail, some other operation needs to happen, I can also publish a message to a topic. And then another subscriber to that topic can then kick off the next event. So you have this architecture where everything is decoupled. And so we publish a message to a topic. Anyone who needs to respond to that topic answers it or subscribes to it and performs an operation. And then when they are done, if another service needs to be informed, they don't actually need to, let's say, make an HTTP post call to that service, right? They can just also publish that message to another topic. And then that service can subscribe to that particular message. So services can subscribe to different topics and they can also publish their own messages. So you can have a very long chain of events. You have built-in retries when you are configuring it with Cloud Run. So when your service sends some sort of HTTP status code, like maybe 500, the topic will retry your event at a certain point in time, and it uses exponential backoff. So you are able to try the event, you are able to run the event right now, and then let's say after 2 seconds, the event can be retried again, and then it will increase it exponentially till finally it gets back a successful response from Cloud Run, which tells it that okay, the service or that particular subscriber has successfully processed that message. So it will try it maybe in 2 seconds, and then again 4 seconds, and then again 8 seconds, and then again 16. So with exponential backups, you can also configure the maximum exponential backoff it should go. So after a certain exponential backoff, you can basically say, okay, I don't want you to continue sending the messages. And then you can also have some kind of a dead letter topic to basically say that, okay, if you continue trying these messages after a certain point, after a while, and it still continues to fail, then send that message to some topic. So you can use that topic as a way to kind of put together failed messages that are just, if a message consistently fails, you can just put it together into another topic that you then manually handle later, right? So, I mean, if we go into PubSub now, there's just so many things. So we will just go by this and I just understand what it allows us to do. And then if we look at the other thing that we can also do, or the other trigger that we can also have, we have event arc triggers. Event arc triggers, you can think of it as an observer on GCP. So event arc can connect to multiple services in your Google Cloud account. It is through event arc that you are also able to connect to your cloud storage. I think Gemini made some mistakes in their spellings, but that is fine. So you are looking at your Google Cloud Storage bucket. I'm not sure what Baka is, but let's forget about that. So Eventarc just allows you to hook into events that is happening in Google Cloud. So these can be events on your cloud functions, events on your cloud SQL, almost every single service that Google Cloud provides. There are some events that Eventarc allows you to subscribe into. So once the messages are sent to Eventarc, Eventarc can then take that message, send it as JSON to your Cloud Run service, and then your Cloud Run service can perform the operation on it. If you come to Cloud Run Jobs is not at the moment able to directly integrate into Eventarc, but you can send those messages to a workflow, and then that workflow can send it to your Cloud Run Jobs. That is if you wanted to run that particular event on Cloud Run Jobs. Now, the things to look out for is you need to think about idempotency. I will I will see if I can find the article and then I'll link it to the video. But Google Cloud published a very good article on idempotency that I think you should take a look at if you are interested in designing idempotent applications or idempotent functions or services. The idea here is that if a message comes into your application and you are handling it through events, you want to make sure that you do not process that particular event multiple times. So if there is a file upload and you need to perform some expensive operation like even an AI or ML workload or transforming some images or being able to capture or transcribe some videos into text, you do not want to perform these operations multiple times because they can be expensive to perform. You have to pay for your cloud services and all that. You do not want to perform these events multiple times. So you want to make sure that these operations are idempotent. So you take an example that an order comes in, you need to find out, have I already processed this order? Right, because you might have processed it, but it's just coming back once more. So you need to find out that have I already processed this order? If yes, then that means I don't want to do anything. I don't want to process it again. because there might be some reason that this particular operation or event is being repeated. Especially if you are working with payment providers like Stripe, they can sometimes resend, let's say, webhook events. And so you do not want to rerun the whatever payment actions you have done, else you find yourself in a situation where you are sending multiple emails to your clients. So if you have not processed, then you go ahead to perform the processes. You save the important key and then also the information about that process to your database, and then you are like, oh, okay, I've performed this operation. So you return 200, right? So you just need to think about and make sure that your operations are idempotent. And we are just going to show an example of some form of idempotent operation when we look at the demo in a short while. Now, these are some of the key points you should look at. Asynchronous makes your apps resilient, right? So this makes sure that if some part of your process crashes, you make sure that the other part of your process can still continue anyways. You can use scheduler when you want to run some operation based on or at a certain point in time. You can use scheduler for that. And scheduler is normally used when you want those operations repeated. If you want it to run only at one point in time, then you can probably have it in a cloud run job or a cloud run service and then run it at a certain point in time, right? Run it only when you want to. You can even tap into Google Cloud's APIs to even run your services programmatically. So that is even an option. And I've tapped into that before where I needed to run my service manually myself without necessarily taking advantage of cloud scheduler. You can use PubSub if you want to decouple your events, if you want to ensure that your events are run at a certain point in time, and always make sure that you are idempotent so you handle duplicates gracefully. Right. Now let's just jump into a demo of this whole solution. So what we have here is a service that allows you to upload an image. And once you upload an image, the service is subscribed to cloud storage based on using Eventarc. So the service is subscribed to cloud storage, and then once an image is uploaded into cloud storage, that service goes ahead to sorry, the same service goes ahead to then process the event. So it's best to just show it. So when we come to Cloud Run, this is the service, and we can just open up the service right now. So the service just has just a few configurations, right? So if I'm to show that quickly, just a few codes. So we have the container. The container is listening on a port, and the only variables we have is an upload bucket. That means that when you upload a new image, where the bucket it should go to. And then let's see what else. I think that's mostly it. I just configured a maximum number of instances, and I also made sure to attach to it a service account, right? Because we need access to cloud storage, and we also need to be able to receive events. Now, if I were to come to my IAM, just to look at, so I'll just delete this. I think it was a test I did. So we have everything. Yeah. Okay. So if we look at the service, we can see now there are a lot of roles, but the ones to focus on is the storage object admin, allowing the service account to be able to perform operations on the storage, and then also the event arc event receiver. So if you need the service to be able to receive events from event arc, then you need to also add this role. So this role is what the service needs if it needed to receive events from Eventarc. And this one, because we are communicating with cloud storage, we also need the storage object admin to allow it to save files and to also view the files or download the files. So now in a typical service like this where we want to basically upload images and then we want to resize those images. If we are going through the synchronous flow, then what will happen is that once the user upload the images, right, and it takes even let's say 30 seconds or a minute for the of course that is a bit too much. If it takes let's say around maybe roughly let's say 5 to 10 seconds for the image to be uploaded, then that means that if you want to perform the resizing of the image whilst the user still still is waiting for the upload to complete, then that means the whatever amount of time that operation for the resizing takes, the user still needs to wait for that amount of time. And that is not what we want in this case. So we can take advantage of Eventarc and then also the ability to perform operations after a certain amount of time to make sure that our service does not, hog the user and does not basically say, okay, the user needs to wait for all of the operations to complete before they can see a successful response. So they can first see a successful response, and then in the background, the cloud event arc will then receive that event that, oh, a new file has been uploaded into the storage. So it will then call your function once more. So we take a look at this. Let's take a look at the event. So if we have no event, then we can go ahead to just upload any file at all. So I will go ahead to upload this file, and the file will go to our cloud storage. We should get, the file path. So it's been uploaded. So if we refresh our storage, we should see the new file uploaded right here. So we have the new file right here, construction worker. Now, I have not yet configured the event arc trigger, and so that is why we are not having any resizing operation in place. But let us go ahead to just configure the event arc trigger. So once you come to your Cloud Run service, you can go to triggers and you can go to add a trigger. Now you can configure PubSub, you can configure cloud storage, Firestore. All these are mostly powered by Eventarc. But if you want some other events, then you can go ahead to try out this option. You can even receive third-party events. I think you have Datadog that you can also receive events from. So if you try to Google Cloud Sources, you can see here that you have so many other options. Your Cloud DNS, your Cloud IAM. If you try even just one of them to see what are some of the events that appear under it. I'm not sure which one would be more suitable to just try out to see. Let's see serverless VPC access. So once you come to serverless VPC access, you can then see that there are so many events you can tap into. So you can tap into get connector event when someone gets a connector, when there is a list connectors operation, when there is a create connectors operation. So when any of these events happen, you can tap into. I want to see if the networking, let's see, which one do we have? Networking services. So let's see what events we have in networking services. So you can see when an endpoint policy is created, when a GPC route is created. Well, sorry, I think it was what was it? gRPC, a gRPC route is created when a network service, what is that? TIT, TCP route is created. Some of these events you would have to be a bit more specific to Google Cloud network services to be able to understand them. But you can tap into all these different types of events that comes from your Google Cloud services. And so this is very good if you want to perform some operation based on any type of event that happens in Google Cloud. You can try to see if Google Cloud provides it through event trigger and then go ahead to perform some operation, right? So you can even do it when a service account is created, you want to perform, maybe you want to send yourself an email when a service account is created based on some internal policy, you can do that through Eventarc trigger. Now, the trigger that we want to use is cloud storage. And Google Cloud just makes it easier because these are common triggers that people go for. So PubSub, cloud storage, and then Firestore, right? So if you had a network of events or decoupled services, and then you wanted to trigger something when um, a message is published to a certain PubSub topic, then you can use this. In our case, we'll just go with the cloud storage trigger, and then we will just call this our cloud run storage, event trigger. I'll just add something like now to it. And what we want is the finalized event. So we want when a new object is successfully created in the bucket. You can also listen to other events like when an object is permanently deleted, when a bucket is created. So you have all of these events that you can listen into, but you want to look at the object finalized. So what is the event data type going to be? So it's going to just be application JSON, which is going to be sent to your application. And you are going to select the bucket. So I'm going to say this bucket. So when there's an image sent to or a file sent to this bucket, that's when I want you to trigger this event. For now, we'll still go with our service account, and you can specify what path on your service should the event be sent to. In our application, we configured another path. So you might have a use case where you only want to call a particular service. So normally you will probably send it to your root or your slash route. But if you have if you have multiple endpoints on your service, then you can configure a specific endpoint to just handle that event. In our use case, we didn't want to build multiple events, but you might want to build multiple events for your use case. So we didn't want to build multiple events, but we used slash event. So what I can do is I'll just go to slash event. I'll configure that route, and then you can go ahead to save your trigger, or you can go ahead to add different labels if you wanted. So I wanted to send it to the path slash event, and then I'll save that trigger. Now, whilst that is being performed, I'll just mention something about idempotency. I'll just mention something about idempotency. So now, when you receive the event, if you are using something like Cloud Functions and you are using the functions framework, you are able to listen, or you are able to provide, let's say, function, Google Function Framework, Cloud Events. Let's see, Google Function Framework, Google Function Framework, Google Function Framework. So you can have function triggers, right? So you can have different function triggers, and you are able to listen to this event. I'm not sure if there's a simple example here. Let's let's see if there's a simple example shown here. I'm not sure. There's not a simple, but if you are using the functions framework and you're using Cloud Function, you can just tap into the cloud events, because you are able to get a cloud event that you can import from the functions framework. But if you are doing it manually, you also have the opportunity to use the cloud events package, right? And then you can basically import from HTTP. So because in this case, we are receiving an HTTP request. So what you can see here in our events function is we are using that function, and then we are passing into it the request headers from our Flask API, and then also we are passing into it the request get data. So this is going to get the data and the request headers, and then it's just going to create a cloud event for us. You can also access the information manually by using the request JSON, right? So if you use the request JSON, request.get JSON, you can also get the information about the event. But to simplify it and then use cloud events so that you can easily just access the event information, we just go ahead to use events. We just go ahead to use the cloud events package, and then we can access it. So there is also, I think, a Node SDK if you are using Node, so you can use that. So we just access the event data. Now, one of the things we try to do to ensure idempotency is we try to create an idempotency key using the bucket name, the object name, and then the generation. So once you get the event from Google Cloud, it will include some information. So this is the information that the event will include. You can look at the objects. So I'll attach this in the notes, and it will include information like the name, the bucket, the generation, and you can look here. You can just scroll down here to understand each property and what it contains. And all of this information will be on the event data. So it will be on the event.data and you can access it there. So we basically just have a function that just extracts that, and you can just simply do it like event data dot something, right? Event data, because it's just going to be a dictionary. So you can just do event data dot something, and then you can extract that data from it. So we are getting the generation. The generation is basically a unique floating number that will be generated for your file. So for the same file, even if you receive the event multiple times, or for the same operation, if you upload a file for that same operation, the generation will consistently be the same. So we can depend on that generation to create a unique key for the operation to make sure that we have idempotency. Another option is you can just use the event.id as your idempotent key, because Google will basically attach an ID to your event. Let's see. You probably have to get it through event.getData, and then you probably have to get it through like the ID. So you have something like maybe get, uh, I'm just forgetting my Python functions. And so you have the event data and then maybe the ID, right? You can probably use the event ID to get this information, but the ID should also exist on the event. That is something I have to look into perhaps after this. But there should be an ID also in the event, which you can probably use as your idempotent key, right? Cloud events should have some form of they when the event is sent, it should have some form of ID that you can tap into. For us, we are just trying to create our own through the information passed into the the data of the event. So that is our bucket, our object name, and then some generation. So we are trying to create an idempotent key here, and then what we are doing is we are just putting that into, we are just obtaining some kind of a lock on our thread. And then we are just putting that idempotent key into some of the idempotent store, right? Now, this is not what you would want to do in a production service, because what we are doing here, we are just saving some global variable, as you can see here, idempotent store. We are just saving some global variable, and then we are maintaining the idempotent keys there. So if we perform an operation for a certain bucket, we would just go ahead and then save some key, as you can see here. So you can see that we have some key, so some idempotent key, and inside it, we will just store some information about the status of that event. So whether it's completed, whether it failed, the blob destination, the time it was uploaded, and if there was any error message, we will save that. But we are maintaining it in memory. What this means is that if our Cloud Run service spins up a new instance, we will no longer have that idempotent store, because it will now be a new service. And so the idempotency store will now be an empty object, because all of that data is being stored in the previous, instance of our application. So if your application scales up, this will not work. But this is just good for our use case, because I didn't want to spin up a database just to kind of test idempotency. So I'm just using a global variable for this use case. But in production, you wouldn't want to use something like this. You would want to use a database and then put your idempotent information there, because by doing this, if your cloud run service scales up or down, you will lose the idempotent key. So if your cloud run service you have spin up, let's just say there is one instance spin up and it is handling the event, and for some reason the event is recent once more, the same event is recent once more, then that event is passed onto another instance of your application. Let's just say a second instance of your application is spin up to handle that new event, then you will have an issue because it will not have the idempotent information about the first instance, because this is being stored like globally in the instance. So you wouldn't want to do that, but it's just for us to, in this demo, provide an example. So you can see here we try to obtain a lock to make sure that no multiple operations are being performed whilst we are performing this operation. So we obtain just a lock, and then we try to get the idempotency key. So if it exists, then we just check the status. If it is completed, we are like, hey, we have already completed this. So we just send back a response like, hey, we have already completed this process. So we inform PubSub or whatever event is triggering, or whatever process is triggering our service that, hey, this is successful, right? And if it is processing, then we also send back some kind of a message to say, hey, there is some other operation that is basically handling this particular idempotent key or this particular item. If it is failed, then we also send back the error message the inside the our idempotency store, right? And then we go ahead to perform the various operations to download the file. And same thing, we make sure that if there's an exception, we go ahead to also update that idempotency store to say that the status is failed. And finally, once every operation succeeds, we now go ahead to update our idempotency store to say that, okay, we have finally completed this particular operation for our idempotency key. Right. So this is how you can ensure idempotency, but this is just a very short example, and this is not also how your production state might look like, because in production you want to make sure you are saving it to an actual database or some Redis cache or something like that, and not something like this, because you do not want to lose the idempotency state of your applications. You do not want to lose the idempotency state of your processes when the instance is, like, let's just say, shut down by Cloud Run or a new instance is spin up. But for our demo purpose, it's fine because we are just uploading a single file and then one process is being performed. And that is, I am the only person. But in production, multiple people might be uploading the file at the same time, which might cause multiple services to be spin up. So that is not the best in production, but this is fine for our use case. So our trigger has been created, and for the trigger, we just used our own service account, but in production, you might probably also want to use a different service account for the trigger. So in that case, you might need to grant that service account the ability to invoke your Cloud Run service, right? So it needs the Cloud Run invoker role, right? We have granted the Cloud Run admin role, which should have the Cloud Run invoker role. So the trigger should be able to call our Cloud Run service. But you might need to separate the service accounts and create a different service account for your trigger and give it the ability to be able to invoke your Cloud Run service. So the trigger is set up, so we'll go ahead and try to upload another file. Let us try to upload a new file. Okay, so let's select a file. This time, let's go with our mysterious detective and let's upload our detective. Right, so we have a successful upload of our detective, and let's just refresh, and we can see here. So you can see that the operation even happens so quickly that, once we just refresh our cloud storage, the resizing has already been done, right? So the operation just happens so quickly. So we have our detective image. You can see the original here. If we just try to open it, you should see the original image right here. So that is our detective. And if we go into the resized folder, we should then see a new one with even a smaller size. And if we try to just, click on this, which should then open it up, you should see 100 by 100 resized image of the detective. So you can see that the operation was actually very quick, right? Because once the upload event happens, the event arc will quickly receive that event, and then it will quickly call our cloud and service that, hey, this event has happened, and then it will send it to the endpoint we configured, which is slash event. And so through that endpoint, you can then perform any operations that you want to do. So you can see here that there are some logs about that event. There are some logs about that event happening. I just want to see, yeah, GCS notification. Yeah, so there are some logs about that event happening, right? And so we have ensured idempotency to make sure that, we are not repeating the operation multiple times, right? Even if the event is sent multiple times, we are not repeating it multiple times. And we are ensuring that we do not hog the user. So once the user uploads the file, they don't have to stay here for the whole process to complete before they see the resized file. And you can see the operation is even fast. So if you were to even have the user if the user even needed to also see the resized image as soon as possible, you can see that the user does not probably need to wait for a fairly long amount of time, because immediately we finished uploading and we came here, we could easily see that resized image. So if we try even with another file, because it's kind of like the event happens, your cloud run service is triggered. So it's just as quick as if you were doing it whilst the user was waiting for the upload, right? Because once the event happens, Eventarc just quickly triggers your service and your service proceeds to perform the operation. Right, so we have another one happening. So let's just refresh. Let's come back to this folder. We should see artist, right? And let's come back to the resized, and you should see, it's just very quick. We should see the resized artist image. So it's just very quick. The operation is very quick. So this is how you can handle asynchronous processes. So you can tap into event trigger, and you can tap into all sorts of events in your cloud run, in your Google Cloud environment, and then perform further operations once that event completes. So thank you, and join me tomorrow for our next topic on health checks and probes in Cloud Run.